Welcome to Chapter 5 IGCSE Environmental Management. And here we'll be looking at Ocean and Fisheries, which is part of our series on quick revisions. Quick revision. So, quickly, the first thing you need to know, what are the major resources that is found within the ocean? So the major resources within the oceans are you can get food, such as marine organisms that are good for eating, food, chemicals, and chemicals here we can get things like salt, building materials, so you can get sand that is used for construction from the ocean. So wave and tidal energy that is also used to generate electricity from ocean. Then tourism, transport, such as when you have your ship vessels that aid in international trade. You can get this from ocean also. So potential for safe drinking water. So water can be purified through the process of desalination. Desalination, that is removal of the salt content that is found within ocean water and make it suitable for drinking. So you see, these are five major importance of the ocean or resources, sorry, five major resources that is found within the ocean. Then next we look at world fisheries. So the position of major cold and warm ocean current. So you see, in this aspect, the names are not required. So nobody is going to ask you what is the name of this current or the name of that current. No, you should just be able to tell us that, or be able to identify which is warm, which is cold, and what is the importance in the relationship between warm and cold ocean current in relation to world fish distribution. So quickly, so let's look at a world map that displays this different ocean current. So I have this here. This is a world map. So I'll just explain a series of um, criteria that will help you to identify the difference between a warm current and a cold current in relation to this. So you see, first, okay, sorry, let me just zoom it in a little. Okay, I have this. So I have cold current and I have warm current. So if you look at this key here, the blue dotted lines are cold current, while the red lines are warm current. Now the first thing you should know is the cold current flows from the equator upward, so north and south of the equator. So if this is the line that separates the world into two equal halves called the equator. So if you look at the warm current, it moves from the equator upwards. It's moving upwards, it's moving upwards, it's moving upwards. And it's either moving north upwards or it's moving downwards to the south or downwards like this to the south. So, meaning warm current moves away from the equator. Equator. And I'm not going to explain how it leads to rainfall here. But as it moves, it rises, condenses, and falls as rain. So you have torrential rainfall here. But you find out that the cold current moves towards the equator. Now, that means the cold current comes from beneath the ocean and moves up towards the equator. So, from both from north and south. So, from the north, you see it coming down towards the equator. This is coming down, moving up towards the equator. So, the cold current move towards the equator. And once they get to the equator, they get heated by the sun. It becomes warm, then it moves up. So, leading to this pattern of circulation. But nobody's going to ask you California current, South American current. No, I think when we just look at the El Nino and La Nina phenomena, that is the major aspect that you might get questions on. Now, the distribution of major marine fish population. Now, how is fish distributed within the ocean? Now, obviously, if this is the continental cross and this is the oceanic cross and this is the ocean, so within this area here is where we call the continental shelf. We have the continental slope, we have the ocean rise and the ocean floor or ocean deep. This is also an ocean deep. Now, around this continental shelf, you find out that first thing you need to look at is that the depth here is low. So that means this area is shallow. So obviously, because it's shallow, there is what? More oxygen. More oxygen. Now, sunlight, there will be more sunlight. So more sunlight will be able to penetrate through. More sunlight. There will also be more carbon dioxide gas. More CO2 gas can penetrate through. Now, if that is the case, because of it is shallow, now that area is shallow, so that means it's not too deep. So now you need this sunlight and carbon dioxide in order for the plants that are found within this continental shelf to undergo the process of photosynthesis. Now, once these plants photosynthesize, what will now happen is what that signifies that there is more food around this continental shelf. That this continental shelf have what? More food. Now, also, that means marine organisms that are herbivores can easily have a high population here because there is ready-made food for them to feed on. So that makes the continental shelf to be, based on those characteristics, it is actually favorable to what? Life. Now, also, once these organisms feed on them, they have to respire. And since there is enough oxygen, that means respiration can take place there. And this respiration is used to what? Provide energy. Provide energy for organisms there. So if you look at around the continental shelf, there is high, because of this reason, that means that is why around the continental shelf there is high fish distribution. High fish distribution. Now, so you see, a continental shelf is the portion of the continent that is submerged under area of relatively shallow water known as the shelf sea. Now, what are the reasons for high fish population on continental shelf? Now, one of the reasons is that it has high oxygen concentration, high light penetration, abundance of carbon dioxide for photosynthesis by phytoplankton, which are aquatic producers. Now, due to phytoplankton, there are a lot of zooplankton on continental shelf because of it means it has high abundance of food. Now, another reason that affects fish distribution within the ocean is the concept of cold and warm ocean current on fish distribution. So cold and warm ocean current on fish distribution. So the cold and warm current that we've just looked at have a major impact on fish distribution. One of those impacts is salinity. What this simply means is the cold current have low salinity, while sorry about this, please. Need to check something. Pam. Okay. Sorry for that short break. Now, cold and warm current on fish distribution. So we look at some of these features that take place within the ocean and how it affects fish distribution. Then we'll be able to tell if areas with cold current will have more fish than areas with warm current. So in terms of salinity, that has to do with the salt content. Cold current usually have low amount of salinity, but warm current have high salinity. In terms of density, cold current is more dense, high density than warm current. In terms of temperature, cold current have low temperature, that's why it's cold in the first place, while warm current have high temperature. Flow, cold currents normally flow from beneath the ocean to the surface, while warm current flows at the surface of the ocean. So if you have an ocean bank, you find out that cold current normally comes from beneath to the surface. So as a result, this process of moving of current from the beneath to the surface of the water is known as upwelling. upwelling. And as it comes to the surface, it brings along with it nutrients. That's why in this case, nutrient. Cold currents are usually high in nutrients due to upwelling from beneath the ocean, which is good for fish food. While warm current is poor in nutrient, and in that case, you find out that cold currents normally have high distribution of fish than warm current. So if in the exam you're asked to differentiate between cold and warm current, these are the criteria you use to just get your full answer. Now, we're also going to look at something very important, which is describe the El Nino Southern Oscillation phenomena and its effect on fisheries along the Pacific coast of South America. Now, this is quite simple. El Nino simply means little boy, I think, in French, in Spanish, thereabout. So, the El Nino Southern Oscillation is the term used to describe changes in the weather patterns in the Pacific Ocean. So, if it is changes in the weather pattern in the Pacific Ocean, for you to now understand fully how El Nino Southern Oscillation affect fish distribution, you need to understand two things. One, you should know how the weather pattern is on a normal year. So you need to know the weather pattern in a normal year, and you now need to compare it with the weather pattern in an El Nino year. Then you now be able to tell how this phenomena that occurs affect what fish distribution. So let's fly. Now, quickly, now you have it occur, this phenomenon actually occur within the Pacific Ocean, and it involves two major currents. So you need to know the name of those currents. So it has two currents, which first is the Peruvian current, which is along the coast of South America, basically the west coast. This is west, this is east, this is north, and this is south. So this El Nino Southern Oscillation occur within the east and west part of the eastern part of Australia and the western part of South America. So if you look at that, you'll now be able to know how this movement of current affect fish distribution. So in a normal year, this is what happens in a normal year. What happens is that the warm current is the equatorial wind, forms the warm current because this line here forms is usually the equatorial line. So the warm current now flows westward in a normal year because this direction is the west, while this direction towards this direction is east, while towards this direction is west. So the equatorial warm current move towards the west in a normal year. And if warm current move towards the west, that means when it get to the west, what will happen? The warm current is light, so it will now move up and condense, and once it condenses, it forms cloud and it will now fall down as rain. So during a normal year, there is high amount of rainfall within the eastern coast of Australia because of this warm equatorial trade wind or currents that move towards Australia. But during that same normal year, we have the Peruvian current, which is a cold current. So the cold current, the Peruvian cold current will move up through upwelling. So because it's cold, it has low salinity, it has high amount of nutrient, it has a low temperature. So it comes along with it food to the coast of Peru and South America, thereby leading to high amount of fish within this area because cold current increase the amount of fish distribution. So this is what happens in a normal year. In a normal year, there will be high amount of rainfall within the coast of Australia, basically the eastern coast, because the warm equatorial trade wind moved towards the east, moved towards the west of the Pacific Ocean, and thereby it evaporates, condenses. So there might be high amount of rainfall, which can also lead to flooding during a normal year. But however, because of cold currents, there is less rainfall around Peru, thereby it can lead to drought within this area. However, there will be high amount of what? Um, how will I put it? High amount of fish distributed there. So let's look at what will now happen during an El Nino year. So let me just read this quickly, though I've explained it. It's not something that should. Now, in non-El Nino year, that's a normal year. What happened? The strong warm equatorial trade wind current flow westward from South America towards Australia and Indonesia. Now, when the trade wind reaches the coast of Australia, it has become hot, wet mass which rises up and condenses to form conventional rain. Now, the high conventional rain can lead to flooding. Also, in a normal year, an upwelling of cooler, nutrient-rich current at the coast of South America means there will be high concentration of fish, leading to low amount of rainfall in South America and eventually can cause flooding. Now, in an El Nino year, the opposite not now happens. What happened is the warm equatorial trade wind will now move towards the east. Because remember, if this is your cardinal point, I've said we, WE, north south, never ever smoke weed. And so the equatorial trade will now change direction. In a normal year, it moves towards the west, but in an El Nino year, it changes direction and moves towards the east. And if it moves towards the east, everything that happens in a normal year in the coast of Australia and Indonesia will now be happening in the coast of South America. So the warm equatorial trade wind will now lead to high amount of convectional rain in the coast of South America, which can eventually lead to flooding. And however, it will now reduce the process of upwelling of the Peruvian current, thereby leading to reduction in the amount of fish that is found within the coast of South America. So you see, in an El Nino year, the opposite is the case, weakening the warm equatorial trade wind current flow what? The equatorial trade wind current flow eastward from the coast of Australia, Indonesia towards South America. Now, this will lead to high rainfall in South America with drought condition also in areas such as Australia. Now, lack or no upwelling of cooler rich, nutrient rich water, which will lead to lack of nutrients in South America, therefore decrease the fish and marine creatures within South America. That's what happens. Please, you need to take note of that. It comes out a lot, and I found out over time that students normally have issues with describing those contents relating to El Nino and La Nina conditions. Um, Impact of exploitation of ocean. What impact does it have? So you look at the impact of exploitation of ocean, you look at the impact of overfishing, the impact of bycatch and target species, marine culture and aquaculture. Now in overfishing, overfishing occur when more fish are caught than the population can replace through natural reproduction. When you catch more fish, then it can be replaced through natural reproduction. So, which can lead to extinction of some fish species, obviously. It leads to reduction in biodiversity because some species might also die out and the amount of different organisms reduces. Now, pollution of marine waters can also occur because during this fishing process, you use ships, you use different shipping vessels that make use of oil, so there can be oil leakage. You can also have sound, which can also affect, which causes noise pollution within the water body and eventually can affect the marine organism. So pollution of marine water bodies, oil and liquid spill, chemical and solid element discharge into water bodies by fishing boats, vessels and trawlers often hurt marine life. Now, effect of target and bycatch species. Now, bycatch also has an effect on overfishing. How? It occurs when fishermen come through with large nets to catch bigger fish. Now, many times larger fish and mammals are caught in the net, such as dolphins, sharks, and sea lions, and porpoises. Now, rather than releasing these beautiful creatures back into their habitat, many are sold or disposed of. So those those are now the bycatch because you have a target. Let's say you're there to target let's say you want to catch sharks, possibly. I'm just using that as an example. Sorry, no fish, no type of fish decided to come to my head right now. So let's say you want to catch shark, which is quite large, so you need a very large net. Now, in the process of using that large net, you did not only catch shark. Now, your target is shark, but in that process, you now catch things like you also catch dolphins, um, You also catch sea lions. And now, these sea lions and dolphins were not what brought you to fish that particular day. So they are what we refer to as the bycatch species. They are the bycatch. Now, instead of releasing this bycatch back, you find out that the fishermen normally sell them and derive money from it. So that's an impact of overfishing. Now, mariculture is a specialized branch of aquaculture involved in the cultivation of marine organisms for food and other products in an open ocean. So you see, mariculture take place in an open ocean. So you don't build a specific fish pond or a pond for it. You have an enclosure within the ocean that you cultivate this your marine species. Now, an enclosed section of the ocean or in tanks, but you still use the same water that is in the ocean. So the same similar mimicking the same characteristics that the organism is supposed to be found in. So aquaculture is less commonly spelled aquaculture, or also known as aqua farming, is farming of fish, crustaceans, mollusks, aquatic plants, algae, and other organisms uh, that are needed for consumption and the rest. Now, all those will also reduce impact of overfishing. So, management and harvesting of marine species. See, this part comes out a lot in past papers. If you go through my past papers that I've been treating so far, you'll be able to see a lot of questions that I've done relating to this particular aspect, which is strategies for management of the harvesting of marine species. Now, net size, and mesh size is one strategy you can use to manage the harvesting of marine species. By increasing the size of the holes in the net, it shows that only matured and full-size fish can be caught, and immature fish can escape and eventually breed, allowing the population to recover. Then you have other species-specific method like pole and line method of fishing. Now, pole and line fishing usually means a particular type of rod and line fishing in which fish are attracted to the surface using a bait fish. In the process called churning, and it helps to reduce bycatch. Now, you can introduce fishing quotas, which means setting fishing quotas for European Union countries and for individual fishing vessels, which limits the amount of each species of fish which can be caught at a particular time. Then you can now have closed seasons. Quotas means you can catch this particular number for this particular species, you can catch because of this particular number for this particular species. Another thing is you can have close season. So close season means that you are not supposed to target a particular species of fish for a particular season. Example, you can say between October to December, you are not supposed to target L because it's usually their breeding season. Then you look at protected areas and reserves. Now, protected areas or conservation areas are locations which receive protection because of their recognized natural, ecological, and cultural values. Now, you can also come up with legislative and conservational laws. These are federal and state laws designed with the sole purpose of protecting fish and activity of fisheries, which will aid in conserving fish within the state. Then lastly, we can look at international agreement, implementation and monitoring of some international agreements within international water bodies to help reduce overfishing. Now, that's it from this aspect and from my side. So, thank you so much. We'll still continue with this quick fire revision on environmental management. And if you need any further explanation, you can always watch my video. And please, please, and please, I need you to recommend my channel and also subscribe. Thank you. See.